Good morning, everyone. My name is Budi Hartono from Politeknik Negeri Bandung, Indonesia. I will present my research to you entitled Search and Rescue Flight Simulations Utilizing Low-Budget Autonomous Quadcopter and Image Processing Technology. Previous research from other researchers, such as Lakshmanan et al. In 2020, they used ArduPilot 2.8 Mega microcontroller with 1400 kV motor rating. They said that they flew the quadcopter autonomously. However, there was insufficient information regarding how they did it. Another researchers, Plachter and Scherer in 2020, they employ X-Star Premium Quadcopter with NVIDIA Jetson TX2 supercomputer on a module. They use 2 UI camera for image processing purposes. The quadcopter took off with a pilot and landed according to the takeoff paths. This research used the DJI F450 model frame as the basic design, utilizing Autodesk Fusion 360 software by maintaining the dimension and the strength of the model frame using generative design process. The 3D printing frame was made from polylactic acid filament material. Our low-budget quadcopter implemented a FixHop 2.4.8 microcontroller along with a Neo M8N GPS module available on the marketplace. We also use DJI brushless motor with a rating of 920 kV, which is below the rating of the Lakshmanan's motor. This research applied a barometer sensor embedded in the FixHub and a LiDAR sensor to measure the flying height of the quadcopter. We use Mission Planner software, which serves as ground control system. In this research, a series of flight tests were carried out to obtain the first, the PID auto-tune flight test to obtain proportional, integral, and derivative constant that we'll use in the autonomous flight. Second, the altitude hold flight test to ensure quadcopter flew at a fixed height from the ground. The following graph shows a comparison of LiDAR and barometer sensing results at a flight height of 2 meters from the ground. It can be seen that the LiDAR sensor sensing results were more constant than the barometer sensor results. Third, return to base flight test to ensure the quadcopter can fly back to the initial takeoff location. Fourth, autonomous flight test between waypoints. 5 waypoint coordinate data were input into the mission planner. This flight test aims to ensure the quadcopter can fly takeoff, altitude hold, waypoint navigation, and landing according to the mission planner's orders to FixHop, and was carried out autonomously. This research applied an image processing system consisting of a Raspberry Pi 3 Model B Plus with a 5-megapixel Raspberry camera module to scan red cycle markers. Programming on the Raspberry Pi uses the Python programming language with OpenCV library. For specific purposes of marker scanning in this study, the hue, saturation, and value range must be appropriate. The HSV range is obtained by trying each value. For example, if we change the saturation input range rather than 5 to 40, grass was also included in the threshold. Search and rescue flight simulation were carried out by flying the quadcopter from takeoff to the second point navigation, which was 11 meters away, while the marker was placed at a distance of 7 meters from the takeoff location. The image processing system was activated from takeoff and senses the ground surface to look for the markers. If the markers was recognized by image processing system as a target, the quadcopter will land on the marker autonomously. However, if the marker was not recognized, the quadcopter will stop at the second navigation point, then perform return to base maneuver and land it autonomously. The research concludes that through utilizing of the Mission Planner software as ground control system, low-budget quadcopter could fly autonomously from takeoff, altitude hold, waypoints, navigation, and landing. Raspberry Pi gave command to fix hop, to landing at a detected marker, or perform return to base maneuver alternatively. Utilizing 5-megapixel Raspberry camera module possessed with frame resolution 1280 by 720 pixels, possess inherent constraint. That is, it only have maximum 3 meters high to recognize the marker on the ground. The quadcopter attained a maximum speed of 3 meters per second when positioned 2 meters above the ground, and a top speed of 1 meter per second when flying at an altitude of 3 meters. Search and rescue flight simulations in this research employs fixed hop to fly autonomous quadcopter and Raspberry Pi to manage image processing. In the future research, Raspberry Pi will fly autonomous quadcopter and manage image processing altogether. That's my presentation. Thank you for your attention.